Hey everyone, and welcome to another video. In the previous video, we saw how we can create a Flutter drawer, which is our own custom drawer, and how we can apply the open and the close functions to that. In this one, we are going to talk about how we can use the gesture detector to kind of implement the dragging functionality with the animation. So the user will be able to drag the drawer and open it, and also drag it back to close it. And in this video, you're going to learn a lot of things, so stay tuned and let's get started. First of all, what I'm going to do is we do have this variable here, the mag slide. So I'm actually going to take it out of the build and move it above at the top, because we are going to create more variables later on as well anyways. So I'm going to move it here, and then I'm going to basically just say static const, and then we are going to make it max slide. Now this should basically change nothing because we have just moved the variable. So one thing that we need to understand about this slide gesture is that when the user is going to open the drawer from left, the user is going to tap or start dragging somewhat around here. So it's from the 0 pixel to some number. Let's say we can keep it 60 or maybe 100 even, doesn't matter. But for the sake of simplicity, we can go with 60. So let's say we create a constant called slide left start well, and then we are going to call it 60. And when this is opened and the user wants to drag it back left, which means the user is trying to close this drawer, then we should be able to just drag it from this inner content, which is the actual content, and also from somewhat around here, which means that we should have some space even behind this border, like on the left. So for that, what we can do is that we can use the mag slide value. So we can say static const slide. Oh, actually, I'm going to change this to slide right start well and slide left start well. And I can say max slide, and then I can use any variable here. For instance, for the sake of simplicity, I can say 20. So this is going to be like 255 minus 20, which is like 235, which means that anything after 235 is considered as the starting point when we are trying to drag left. Okay, and I can also call these drag instead of slide. So let's change that. Now that we have the variables in place, the first thing that we need to do is to make sure that we are sliding or we start dragging. So in order to do so, I'm going to go to the gesture detector, and here we have to add some handlers. So for the first one, we can say onHorizontalDragStart, and here we are going to create a function and we'll call it onDragStart. Now let's create this function. So we can simply say void onDragStart, and this is going to basically take a parameter here. So basically this takes a parameter called start drag details or drag start details, and we can say start details, and now we are good. So what we are going to do is that we can just rely on this variable, and then we can print the value right here on what this offers us. And the value that we are interested in right now is something called global position.dx, and this is exactly where do we start dragging on the screen. So whatever variable that is, that's going to be printed out right here. So I'm going to save this right now, and then now we can start dragging. So let's say if I just do this, you can see that we got 247. If I click here and drag, you can see that we got 3 because it was so close to the screen. If I do something like here, then we got something like 69. So I think we got the value 60 here, which is perhaps really good for our use case. So now that we have this value, the next step is to identify if we are dragging it right or wrong, which means that if the drawer is closed and if I start dragging from the middle, should it actually open the drawer? I don't think so. It should start opening the drawer when I start dragging from the very left. And similarly, if I have the drawer open and if I start dragging left from here, then should it be closed? Nope, that doesn't need to be closed in that way. So in order to make sure that we are doing it right, we are going to put some conditions right there. So what we can do here is that we can say bool, and then we are going to have a variable for opening the drawer. So we can say is dragging from left, and we are going to first check if the drawer is opened, and we check that by controller dot is dismissed. So if it is dismissed, that means we have the drawer closed right now. And we are going to check if start details dot global position dot dx is less than what we call this variable, which is drag right start well. So we are going to use this one. Now this means that we are dragging from left towards right. Similarly, we are going to have another condition. So we are going to say is dragging from right, and this will be controller dot is dismissed, but we are going to have a negation at the start. So this means that it is not dismissed and it is opened. And if the start details dot global position dot dx is greater than the drag left start well, this means that we are actually dragging from right and we are calculating everything in a good manner. Now we have to keep one variable in kind of a global state like here to make sure that we know when we are updating the animation value if we are dragging or if we are not dragging. So for that we can create another constant here. We can say static const, and we can basically call it should drag equals false, and this will not be a const. We can say bool, and then we are basically going to update this variable here. So what we'll do here is that we'll say should drag equals, and then we'll say is dragging from left. So either if it's dragging from left or if it's dragging from right, then we say hey, should drag is equals true, because now we can update the animation's value. Okay, and this is good enough so far. Now we have to focus on how do we update the position of this whole content while we are dragging, and for that we need to work on the update method. So we are going to go ahead and we'll just say onHorizontalDragUpdate, and we are going to assign a new function here that we are going to create. So we'll say onDragUpdate, and let's create that function here real quick. I'm just going to do a copy pasta here, and then I'm going to say update, and then this is going to be drag update details, and we can call it update details. I really like how the Android Studio suggests the name as I start writing it, because this update details doesn't exist in the code so far, but I really like how it suggests it. Now in this function we are going to focus on another property called primary delta, and I'm going to just print it for you so we can see what that means. So we are going to say update details dot, and then we have this primary delta property. Now if we hover over this, let's see what this tells us. If we go here, so what happens is that this is the amount the pointer has moved along in the primary axis in the coordinate space of the event receiver since the previous update. So this delta is always the latest movement from the previous update. So it's always going to be really minimal. For instance, if I move 1 pixel each time, the value of primary delta would be 1 pixel because I'm moving pixel by pixel. This doesn't mean anything so far unless we compare it with something bigger. So for instance, I need to compare the primary delta by pixels on how much I want to make this slide. So you know that this slide that we do is from 0 to 255, I believe. Yes, exactly. And we want to be able to compare this value with the max slide. So what we are going to do is that we are going to put max slide here, and this basically results in a value that we can use within the animation. So what I'm going to do is I'm going to just create a variable called delta, and then I'm going to use this value and save it there. And then I can basically print this delta value here for now, and then we are going to see what this shows. So if I move this along, you can see the value that we have is 0.056. It's almost the same with just some variation, but this gives us a value. Now this means that this is the amount that I move every time there is an update while I'm dragging. So what we need to do is that we need to add this value to the animations value, and we do that by something called controller.value, and then we do a plus equals delta, and that's all we need to do. So if I just save this, and now if I start dragging this, you can see that it starts moving forward and it adds the value to the animation to the point that it reaches 1. And when it reaches 1, then we basically are at the point of 255, and that's what we actually want. So this is actually really smooth right now on how it works. So when we move forward, we get a delta in a value that is a positive value. But if we move in the negative direction, you can see that the value is in negative, which basically helps us move backward. So you can see that the dragging right now works and it's actually flawless. The only problem right now is that I can actually start dragging from here and it still works. And this is what we didn't want. We don't want to start dragging from here. So what can we do about that? We already have a should drag variable that we can use. So what I'm going to do is that I can simply say if should drag equals false, then we don't do anything, we just return. And that's it. So if I save this now, and if I start dragging from here, you can see that it doesn't work. If I start dragging from here, it doesn't work because the drawer right now is open. So it will only work if I start dragging from the very left. And you can see it works from here. Now the animation is completed, and now if I start dragging from here, it doesn't work. If I start dragging from somewhat here, you will see it works because we have that -20 in the calculation. Where did we put it? Here. And if I start from here, it would also work. So you can see that it works amazingly so far. We might have one issue, and that is if I start dragging from here and if I leave in the middle, you can see that this drawer is in the middle, and that is not what you would expect from a drawer, would you? So if I start dragging right now from here further, it doesn't work. Why it doesn't work? Because at this point, the controller is not in a state that is called dismissed. So you can see that its dragging from left relies on this state which says controller is dismissed, which means that the drawer should be closed. And right now I'm in the middle, so this wouldn't work because it will not consider me dragging it from left, and that is a problem right now. So how do we solve this issue? We are going to solve this in the next method, which is when we end the drag. So for that, we are going to create a new handler here. So that would be onHorizontalDragEnd. I can call it onDragEnd. And now we are going to create a function for that as well here. Copy pasta onDragEnd. And now this is going to be dragEnd details. DragEnd details, really good. And now what we want to do here is that if I start dragging and if I leave this in the middle, and if it is not halfway through the animation, then it should automatically go in the initial state. For that, we can write some code here. We can say, hey, if the controller dot value when we drag end is less than 5, or not exactly 5, but it's 0.5 because it's from 0 to 1. So if we have the controller value less than 0.5, then what we do, we just close the drawer, and that's it. So if I start dragging right now and if I leave it, see how it closes. So it comes to this condition, sees the value of the controller, and then it does this. And if you want to check this, you can simply print here the controller dot value. And let's try this out now. I'm going to remove the controller, or not the controller, but the print from here. And now let's try this. So if I start dragging and if I leave, you can see the value was 0.05 and not 0.5. If I move it further here, you can see it closes again. The value was 0.3. But if I try to make it like here, then you see that the value was 0.6 and it still is opened. Now, if we have moved half past the whole slide, what should happen? So in that case, we need to open the drawer. So let's save this and try this out. So I'm gonna start dragging, leave it, and if I move halfway, you can see that it opens it. And that is what you would expect. Now the only problem that we are left with right now is the user will not usually do this halfway movement in order to open the drawer, right? I mean, you can see that I'm trying to open it just like I would do in any other application, but it doesn't. Most of the time it just closes. Why? Because I haven't moved this halfway, and this is a really bad user experience. So how do we try to solve this one? Now, there is something called Fling that we can use in order to make sure that, hey, if I'm dragging this at a particular speed, then go all the way forward. Otherwise, just do what you are doing right now. And this is something that the Flutter drawer component, which is the core Flutter drawer component, does out of the box. And the code is basically inspired highly from there, what I'm going to write now. So I'm going to show you how this looks in the repository. So if you go to the Flutter repository and go to Flutter packages, Flutter lib source material, drawer ... you can try to find Fling or k-min Fling velocity, and you'll find this variable right here, which is somewhat around 365. I'm not sure what this means, but it is there. And if you try to find the usage, you can see that they're calculating what is the pixel per second velocity right now. They take the absolute of it and then they compare it if it's more than the velocity or less than the velocity. And then they try to just do some magic calculation here. So our implementation would be really simple, but around the same concept. So let's go back to the code and try this out. So now we can create a variable and we can call it double, let's say k-min Fling velocity. And let's say we assign it to the same value as them. We say 365.0. So now we need to kind of calculate the velocity on which we are dragging the slider. So we can simply say double drag velocity, and we can get it out from the drag end details dot, and we can call it velocity. And from velocity we have pixel per second, as you saw, and then we have the value of dx, which means in horizontal direction, and we are going to take the absolute of it. Now that we have got this, we have to compare it with the k-min Fling velocity, and we can say if we have the drag velocity greater than or equal to the k-min Fling velocity, in this case we need to calculate some things. So what we need to do is we need to calculate this based on the width of the device, and that's how we get the actual visual velocity. And why do we need to do that? Because we have the pixels per second and we need to find out how many pixels are there in the device itself, so we get the actual velocity. And what we get out of that, we can use that within the controller. So what we do here is that we can say double, and we can say something called, let's say, visual velocity, and then we basically say end details or drag end details dot, and then we have velocity, then we have pixel per second, and then we have dx, and then we divide it by media query, which means we are going to get the device width of context, and then we say size, and then we say width. So this will basically calculate the visual velocity in pixel. So we can even call it this if you would like. And then we can say controller dot Fling. We have a variable here, and here we can provide the velocity. So we can say velocity and then visual velocity in pixel. And this will actually allow the animation to do something like a fling or a motion using the velocity that we have. And this should be magical when we execute it. So now that we have got this, we have to make sure that these conditions do not work when we have the velocity in place. So I'm going to use an else here and then just put the if else condition after this one. So let's save this now. And now if I try a really quick motion, you can see that it works. If I move it really quick, it works. If I try to move it slow, you can see that it doesn't work. And we can confirm this obviously when we try to print the drag velocity. So we can try to print this here. And now let's see what the values are. So if I try it slowly, you can see that the value is about 0.0. If I try it fast, you can see that it's 677, which is much higher than 365. So it works. And this is amazing. Now we can actually replicate the behavior that a user would see. Now this is absolutely what we want, but if we just want to make sure that on drag end, if we have this drawer opened or closed, nothing happens, then we can quickly just put a check here, and then we can simply say, hey, if we have the controller dismissed, or if it is dismissed, or if the controller is opened or is completed, as how we call it. So either it's closed or if it's opened, then we simply return. We don't do anything when the drag ends. And now if you try this, you can see that the animation is really smooth. The use cases are covered, as you can see that it doesn't go all the way when we stop right in the middle, or if we go half past, it goes towards the really end, and it also works with the button as well. Alright, so I hope that you learned a lot in this video. You now know how you can implement the gesture detector along with the drag feature for opening and closing the drawer. And we also saw some really end use cases that we have to implement to make sure that the experience for the end user is brilliant. So now I think you are a master of Flutter drawer animation, and that's going to be it for this video. If you have not subscribed to the channel yet, please do it, and then I'll see you later.